You try to screen share mo. Okay. Then you try to screen share muna and then try if your pad is working well. Okay, I can now see your ano. Okay, we're good. Yan. Okay, so going back, good evening po again, Sir J and Josh. So we'll be continuing our nuclear chemistry practice set discussion. So more on ano siya, answers na ito, no? Um, I think we will finish the practice set today, Josh, or hopefully, no, this evening, so that on Saturday we'll have a new topic, no. So new topic na yan, electrochem na ang new topic natin. Okay? And then with that, share ko muna ulit yung um, practice set natin. So last meeting, we had this set A, no, or yung part 1, balancing nuclear reactions and predicting their mode of decays. Medyo madali ito, no? And then we proceeded with this nuclear stability, binding energy, and kinetics. So we ended, I think, in number 6. Okay, so number 6 tayo natapos. So we'll now continue our answering sa number 7. So how much energy is lost or gained? So if it's gained, no? Please take note dito, it's always, Josh, ano nga ulit yung delta E? How will you get the delta E?
Delta,
Regardless
ano
kung nuclear yan or thermo. Delta
E?
E.
E.
Delta E. E, yeah. Delta energy. Or if you
Delta
have
M.
delta,
Delta
pag
M,
delta, it's always,
Delta
yeah,
MC
pwede ring
squared.
delta M. MC, yeah, E is equal to MC squared. But if you're given with a reaction, how will you get the change? Yeah,
Delta
katulad
H
nito, nuclear
plus,
reaction.
Delta H plus
Mhm.
work.
Hindi, what I mean is, kunwari may change ka, ito, how will you, di ba, we can clearly get
Yes,
the delta E here.
products minus reactants.
Very good. Ayun, products minus reactants. So what you need here is the masses of nickel tsaka cobalt 60. Nickel 60, cobalt 60. Binigay naman. If we want to get, parang mas gusto natin, no, na mas tama tayo. Let's also give the mass of electron in AMU. So the mass of electron in AMU is, note mo na lang to siya, at 0 point, so decimal, 3 zeros, then 55. Lagay pala natin, no? Baka pwede ako
Ano po? Ano po
mag-annotate.
yun?
Mass ng electron. Pwede ba ako dito annotate? Oh, text na lang. Ayan.
Ganyan lang po. Para ano.
Mass of E is equal to 0.123. Oh, lumilitaw siya, Josh. Diyan.
Wala pa po,
Sa end
4.
mo.
Or ano, 3 lang po.
Oh. Again, ayan. Nakita mo, Josh? Mass
Apo.
of electrons, 0.00055 AMU. Okay, good. Okay, so for number 7, here is the problem. How much energy is lost or gained? So the sign will be a decision factor there. When a mole of cobalt 60 undergoes beta decay, so that you can form nickel 60 and then of course a beta particle. No? So the mass of cobalt 60 is 59.933819 AMU. Very exact, no? And nickel 60 59.930788. By the way, parang magtataka ka, Josh, how can we get this? Meron tayong instrument called mass spectrometry which can actually accurately measure the masses of your atoms. Kahit ano, isotope man yan or what, na measure natin siya accurately. So mass spectrometry works with magnets. Okay? So yun yung parang pinaka-basis natin dyan. We'll be explaining or dealing more about mass spectrometry, yung mismong instrument sa analytical chemistry. Pero the interpretation of results sa organic chemistry. Ganun
Me
yung
after
discussion
me
diyan
after
eh.
ano po, me
Ah.
after building my own mass spectrometer.
Yeah, kasi magnet yun eh, no? So, and then you need parang literally the atoms or nuclei there are flying. Parang lumilipad sila within your ano no, cavity made of magnets. Tapos kung sino yung mabilis or malalaglag kagad, mabigat sila. Yun yung concept niya. Anyway, babalikan natin yan. Magandang ano yan, discussion. Tsaka maganda yung interpretation yan because it will help you to predict no the structures of organic compounds. So with that, I think I can stop sharing now. Sige, yan na. Na-note mo, may copy ka naman, right, ng problem?
Opo.
Okay? So, ang kailangan lang po natin dyan, ang additional lang na binigay is the mass of electrons in amo. 0.00055 amo. I'll stop sharing muna and then you can now share your screen and solve for number 7. Yan.
Yay! Tang imagine.
Kayang-kaya mo yan. Quite similar naman siya no with parang kumukuha lang din tayo ng mga nuclear binding energy. So coordinate din po muna ako kay Sir James sir para para at least malaman ko kung kaya nyo pong magturo siguro kahit isa or dalawang sessions ng no ng electrochem. So, parang kahit ako po mag-start kasi busy po talaga si Sir James sa Japan. Ano po talaga siya, nagla-lab talaga. So, kaya ano po, pag nagkukwentuhan nga kami minsan, ang available niya lang po talaga ay weekends tsaka kung gabi po okay din. Yun nga lang, kung sa bagay, kung 6 po kasi nag start 7 na po yun sa Japan. Pero parang baka mas kung kaya nating mag-start po ng 7, kung amenable po kayo doon, 8 na po nun sa Japan. Kung pwede siya nun, sir, yun, makakapagturo siya.
Kasi wala. Free na po siya ng time na yun.
Hopefully po. Kasi minsan, alam nyo naman po yung mga Japanese, masyadong, actually hindi lang Japan, sa Asian, no? Masyadong workaholic. Sabi niya,
Opo.
minsan daw, mga alas 12 na daw ng madaling araw, nandun pa rin daw yung ibang labmates niya. Sabi niya, siya uuwi daw talaga. Minsan pa nga
Kaya,
daw po, mga 2 a.m. Grabe.
kaya nga po sinasabi ko sa inyo eh, ako nakita ko kasi po ako, I lived abroad already, no? Tapos
Mhm.
inaano ko kasi sa kay Joshua, sabi ko, okay, pag kunyari, if ever matanggap ka doon sa mga Ivy League, no po?
Mm.
Pero sabi ko, after nag-aral ka, alis ka na rin sa US kasi rat race dun eh. Di ba po?
Oh, yes po.
If you want to earn money, pwede, kaya lang, yun, like, yung mga tinuturuan ko eh, mga parents eh, haras lagi eh.
Ara.
Kaya as
Mm.
much as possible, dapat on time, lahat, saka kasi may pupuntahan pang next, tapos yun, walang time sa mga anak, ganun.
Ayun lang
So,
yung yung
yun
sad
yun
na
po.
part.
Opo,
Yes
yun po
po.
yun sa kaya madaling pera kasi kahit na hindi masyado magagaling, okay pa rin, maganda pa rin ang kita, di ba po? Kaya lang,
Mm.
oh, kaya kayo dun talaga, I would assume na you will be highly esteemed. Kaya lang, pili kayo ng country, kunyari, malaking sweldo doon sa, Josh, hindi makita.
So, saan ko lalagay?
No,
Pag
dito
nilagay ko
dito.
dito. Pag nilagay
Next
ko dito.
line. Ay, wait.
Sa, po, yung bali, ang kunyari, Singapore, okay, malaking kita,
Mm.
kaya lang, yung mga tirahan nila doon, maliliit eh.
Competitive, sobrang competitive sa Singapore. Actually,
Opo,
yung mga Asian countries super competitive, no? Parang mas mahirap pang
opo.
mag-compete kaysa sa Western countries.
Kaya nga po, kaya dapat ano yung, sa ibang country naman, bakit, you only live once eh. Kaya nga, sinasabi ko
Mm.
sa inyo, sir ah, okay, kung pag naka-give back na kayo, think also of yourself. Kasi, in the end, uh, we will only live once, di ba po?
Correct po.
Ano yung, uh, dapat yung what is due you, kasi, ano kayo, you're doing your due diligence, di ba? Ako, para sa akin, ganun
Yeah,
naiiba
oo.
tayo naiiba tayo doon sa karamihan di ba yung mga karamihan, ngayon tamad na di ba? Tayo, nagsisikap pa tayo, nag-aaral. I mean, iba yung ano natin, iniisip ko nga kanina na natutulog pa sila Joshua at sila Julie. Sabi ko, iba yung, we're, we're a different kind. Iba-iba talaga yung tao, sabi ko, no? So, we're a different kind. Tayo, billing tayo mag-ano sila, yung mga, kahit yung mga tinutunan ko, minsan yung mga family parang majority, yung gusto yung pa-easy-easy lang na buhay, no? So, pero kailangan, sabi ko, dapat kamukha natin, kamukha ninyo, kamukha lahat ng mga ibang teacher ni Joshua. For me, dapat, nako-compensate kasi
Oh,
we're
yes.
doing
Tama
them.
po.
We're doing more than them. Sila,
Kaya ano po yung yung ano
easy-easy.
yung medyo ano po yung ano communism eh. Yung mga hard worker hindi binibigyan ng yung fair sa kanila.
Yes. Kaya it will fail. Kasi, ano
Kaya
Yeah.
nga yung kahit yung
Ano
Vietnam
siya,
nga po nag-push kahit na ano
parang,
siya on paper communism, nag-socialize na rin po siya para ano nag-iba na po yung ano nila eh.
Of
Wala na halos pong yung purely except China, wala pong purely ano communist.
oo, ang Vietnam, ano, parang, yung Vietnam nga, parang medyo nagre-relax na yung policy nila sa communism kasi based nga din sa naririnig ko na ano, kasi may mga kakilala po din ako doon, colleagues talaga, nasa Hanoi tsaka sa Ho Chi Minh, mga professor na rin doon. Mukhang ano na sila, well compensated, ibig sabihin, ano na parang kung ano yung wino-work mo talaga, yun na din yung dapat mo ma-receive. Which is policy yun ng ano
government.
ng ah ano nga ito? Commercialism ba to?
Apo,
Mm. Ano
capitalism
po
po.
more on hindi siya talaga ano, hindi na siya pure na ano.
Socialism na po.
Ano na sila talagang mano sila sa business Yun ako po, last time ako pumunta doon. Kaya nga sabi ko pag kung hindi lang nag-pandemic, yun yung mga gusto na sana namin puntahan Para sabi ko masarap yung food sa Vietnam, di ba po? Tapos yun maganda yung mga pupuntahan, maraming adventure Tapos yung mga mura. Ewan ko ngayon, I don't know now kung
Mas mo ay mukhang mura pa rin naman, sir.
tapos masarap
Same
po yung
sa ano.
pagkain. Masarap po yung food.
Oo. Di pa po ako nakakapunta sa ano sa Vietnam, pero Thailand po 'yun. Masarap din yung pagkain doon.
Masarap din, yes.
Mm.
Pagka
Ayun pala, meron ng sagot si Josh. Okay, let's see, no? That is your answer for number 7. So, ang number
Number
7 mo, ang delta mass.
number 1 plus 2 plus 3 plus 4 minus minus 3.
Okay, so your delta mass is,
Ano po,
ano to, negative
pag
2
yung ano niya
point.
po, yung solution, solution requires 500 characters. Me.
Okay, 2481. Oh, what happened?
Yung number na lang po may ano na.
I think ano to, no? Yung delta M mo ay negative 2.481 times 10 to the negative 3 amo. Correct?
Abo.
Yeah, tapos tinimes mo sa 3 times 10 to the 8 meters per second. Correct? Magiging ang delta E mo ngayon ay um, in joules. Correct. So, ano tong reaction na to, Josh? You're expecting what? A release or an absorption of energy?
A release.
Okay. Kasi based dun sa ano mo, calculations nga natin, di ba? Correct. 3.703 times 10 to the uh, negative. Ang akin ay negative 7 kg. So, tama, no? Okay, correct. Negative 10 joules. Correct. Okay, so with that, we're good with number 7. So, ganun lang din yun, Joshua. Kapag meron kang mga problems or if you will encounter nuclear reactions, ganun pa rin. To get the energy involved in that nuclear reaction, ayan, katulad nito, Josh, kitang-kita natin, di ba, recall, pag beta decay, yung tanong mo last time, hindi nag-add up yung electron tsaka yung mass ng antineutrino mo, no, for beta decay, because some of your masses were actually converted into energy, and that is the amount of energy released when specifically this is for cobalt 60, no, na naging nickel 60. So along with your beta particle and antineutrino na marirelease, no, electron antineutrino, you'll also release 3.703 approximately times 10 to the negative 10 joules energy. Okay? So
Opo.
that is per, kung makikita mo ha, sir, parang ang liit nito, negative 10 joule. That's per nuclei. So imagine, no, joule per nuclei. Yan. Lagyan mo na lang pala, Josh, ng joule per nuclei para you'll always recall or you'll always remember pag kinuwan mo to ng picture na per nuclei yung nakakalculate nating energy, change in energy, no, for that. So imaginein mo na lang kung nakagrams yan, it will be multiplied by the number of moles. Okay?
May ano rin
Or
po ako,
number of
tanong
nuclei.
ako. Di ba po yung
Sige.
yung beta, usually yung ano na, yung description of its penetrative power is it can penetrate 1 millimeter sheet of of aluminum foil.
Okay.
So can it be used to measure approximately the width of aluminum foil?
Oh, yeah. So, of course. Alam mo ba, yung mga electrons, Josh, ginagamit natin siya sa microscopy and we can actually measure the nanostructures. Yung mismong ano nila ha, thickness, length, etc. Yan ang basis ng electron microscopy. Because electron can actually penetrate, no, your material, lalo na kapag mga nanostructure na. Yeah, basically we can measure them. Correct. Galing nung analysis mo na yon, kasi nung na-realize ko din na okay, that's actually being used in electron microscopy. Okay? Ayan. So balik tayo kay nuclear chem. This time we're number 8. So ito. Ayan, may disintegration per second na tayo or disintegration per minute. So, please take note, di ba? Recall natin, Josh, no? 1 disintegration per second is equal to anong unit yon?
Becquerel.
Very good. So, it means one nuclei or one nucleus rather is being disintegrated into other forms o kung anumang decay mode yon per second. So, number 8, a freshly isolated sample of yttrium-90, Y90, was found to have an activity of 9.8 times 10 to the 5th disintegrations per minute. So that is how many nuclei of Y90 is being disintegrated per minute at 1 p.m. on December 3, 2003. December 3, 2003. Anong year ka pinanganak, Josh? December 3,
2009.
2000. 2009, wala ka pa nito.
October 15, 2009. Tagal.
Wala ka pa nito. Ano pa lang, pero ako nito ay December 3, 2003. First year high school. At magbe-birthday ako niya kinabukasan. December 4, 2000. Oh, December 4 ako eh.
Sir,
Naalala, nung December po ako, di ba, nagsabi po ako na
Sagittarius din
magbe-birthday
kayo
din.
na, no?
Yes po, sir.
Pinaw tayo. December 8 po ako eh.
Oo nga pala, magkadikit yung ano din natin birthdays nga pala, sir. Naalala ko nga yun na Parang just after my birthday, ako naman yung nag-greet. So,
Ah,
yung mga ano talaga, kaya talaga sir, nagkakaintindihan tayo, mga Sagittarius na friends ko din, medyo ano eh, same wavelength kami.
opo.
Anyway po, ayan. That's 1 p.m. ha. So take note, 1 p.m. December 3, 2003. Kasi mahalaga dito yung time, Josh. We know this because this is kinetics. After that, at 2:15 p.m. ng December 17, 2003, its activity was redetermined and found to be, so from 9.8 times 10 to the 5 disintegrations, umunti na lang, no? Yung Y90 mo. Kasi umuunti ang Y90, Josh, right? Kasi
Opo.
nagde-decay siya. So you expect that disintegrations per minute must be less as well. So that will become 2.6 times 10 to the 4 disintegration per minute. Bakit walang tanong dito? No? Walang tanong?
Tang, tang,
Parang
tang.
half-life ang tanong dyan, alam ko. Double check ko, Joshua.
Ayun.
That's number 8. Yeah, what is the half-life of check ko. Yep. What is the half-life of yttrium-90? Yan lang. Okay? So, what is the half-life? Sulat mo na lang dun sa ano, sa paper. What is the half-life of yttrium-90? Okay. That's number 8.
What is the half-life of ano po? Yttrium 93. The half
90.
the half-life of Yttrium 90.
Y90. Okay.
Ano po
Ayan.
dapat po ganun pag ano wala na po kayong maisip. What is the half-life of Yttrium 90? The time it takes for a sample of Yttrium 90 to become one half of its original size.
Mm-hmm. Oh, make sure na ano ha. Make sure that you know the formula for kinetics.
I don't know anymore. I forgot.
Ay naku, madali naman yun. Paulit-ulit tayo sa kinetics formula. Ayan, very good. Negative KT, correct. So the disintegration of nuclei can be considered as amount as well. So yun yung AT and AO mo.
But
That's your
why?
comparison.
Why
Okay.
why would you base mass po on disintegrations?
Because it's basically the nuclei, right? And
Ah,
nucleus represents your mass. So, ganun din siya. Okay, correct. So, ayan, nag-negative ln to over half-life ka na as your K.
bro. HN. Yan na po.
Okay, so 64.4 hours or double check ko yung answer mo. Number 8. Can you convert it into days? Try mo lang i-convert sa days, Joe.
Imagine using days po. That is a very bad unit. I totally don't use it every day.
Pero 1, 2, 3. Correct. Sige, okay lang yon. Naka-hours, 64.7 hours pa yun. Okay, good. 2.7 days. Ayan, tama ito. So, mag-annotate din ako, no? So, view option. What's the annotation? Okay. So, this is per nucleus and then this is your half-life, no? So, good. Yung 80 mo, that will be the 80, 10 to the 5th. Pa-check ka nito, Josh. Ito mo. Ayan. Why is your 9.8 times 10 to the 5th in the numerator and then nasa denominator naman tong 2.6 times 10 to the 4th?
I don't know. Tama po?
The answer is correct. Pero if you will if you will answer, you'll use that, hindi yan yung lalabas. I'm pretty sure with that. Okay, ayan. Dapat ang 80 mo ay 10 to the 4th, 10 to the 4th, tapos 10 to the 5th. Yan. Okay, this is your 80. Then your AO is this one. Okay? Okay, 2.68 days. Okay. So, ayan. We can now go back sa ating I'll screen share ulit, no? So, mas mouse again. Number 9. Number 9 na tayo. Medyo mahaba-haba yata tong 9. Ito. For number 9, yung parang mo, tanong mo sa radioactive decay or natural radioactivity, no? Consider the decay series A, B, C, and D, no? So where A, B, and C are radioactive isotopes with half-lives of 4.5 seconds, 15 days, and 1 second respectively. And D is non-radioactive. So kung gagawan natin to ng ng series. So ang A going to be, that's the half-life is 4.5 second. Then B going to C, 15 days. Then C going to D, 1 second, no? Then D is non-radioactive. So starting with 1 mole of A daw, so you now have 1 mole of this. Calculate the number of moles of A, B, C, and D left. Ano to? Parang kulang, no? Parang kulang yung Wait lang. Meron bang kadugtong? Left. Oo nga. Okay. Left after 30 days. Wow. Ikaw pala, tinatago mo para wala kang isa-solve. After
Yung
30 days.
1984.
Mhm. After 30 days. Okay, so that will be your number 9. Sige. Stop sharing muna and then you can now share your screen. That's for number 9.
Tang, 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 tang. Kailangan po ng more real estate. So, it has to be demolished.
Sayang wala na yung ice cream na demolish na siya. Dapat ang ginawa mo lang, covered it with, okay, cover that with a white building
Ano
so
po,
that
parang,
it
may
will
ito po
still
yung,
be there.
so, ngayon po na, may nahanap po na, yung Burger King na vintage. Behind the wall.
Oh,
Fully
behind the
intact po.
wall of,
Brick.
behind the wall of what?
Behind the wall in the mall po. Ginamit ng
Oh, okay.
behind yung wall po na ginagamit po ng isang store, nahanap po.
Mhm.
May po may robbery, pero nung
Yeah,
may naputukan yung wall na 'yon. Oh,
yeah.
parang may
Nakita nila
butas po.
merong oo,
May
may
nasa loob sa
extension ng mall. Siguro dati siyang extension ng mall, no? Na
tapos
tapos eventually they
winol na lang po.
abandoned that one.
Winol na lang po. Ah, okay. One more. A, B. Tingnan mo. Where are you, ice cream? Okay, wait na. I will need to move you eventually. Yes, okay. So, ay, ba? One more. Thirty. 30 days. Math error? Bro, ay. Cannot solve. Bro, literally in 1894. Correct. Bum, 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 bum. Grabe po, sobrang minute na nito. Ah, LN.
Yung after 30 days ni
Opo.
A, baka wala na nga eh. Or basta I don't want to give
Negligible na.
clues.
Negligible na. Sobrang ano, di na po kaya ng ano, di na po kaya ng calculator. Ay po lumabas na sa calculator, sobrang laki po ng ano eh. wala talaga, negligible.
That's for letter A. Pakita mo din yung ano, yung formula. Like the ln k yan. ln AT over AO equals negative KT. So that we can clearly see no that no amount of A
Pero
will
po
be
po,
left.
pero talagang parang sobrang it's too minute po. Baka wala na po talagang
Yeah,
atoms. Kasi atoms po are physical eh. So, wala na po siguro.
correct. Or ba wala na talaga. Okay, good. Moles. Negative ln 2 over K. Negative ln 2 over half-life pala. That's your K. Okay, good. Seconds. This is 1 month, right?
Opo.
Okay, continue. So, ibig sabihin, ano, paano naman pag letter B? You start now with letter B, no? Okay, correct. You're doing it good.
Oh yes, I forgot. There are actually kiloseconds. Ah, 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 ah. Ah. Genius.
Conversion factor or conversion function.
Oh wait, I forgot anyway that this is just one
Ah, the
half.
kilosecond.
Just one
Okay.
half anyway. So I will just put 2. This one half anyway pala. 15 days is one half. Okay, good.
So we're calculating with the moles. Josh, you check the letter B formula before you proceed with C. Why do you have over 2 there?
Because yung half-life niya po is 15 days while yung isa 30
Mm-mm.
days.
Oh, ano ang 30 days mo?
Ah, times 2.
That is the
Yay!
time, right? Oh, 'di ba?
Susi! 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 Dang,
OMG.
dang, 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 dang. Me after forgetting basic mathematics po.
No, you don't need to forget that. That's your tool. So, magbabago ngayon yan.
Yay! Dang, 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 dang. Da-da-dang. Dang, 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 dang. Da-da-da-da-da-da-da-da-da-da-dang. Dang, 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 dang. Da-da-dang, da-da-dang, da-da-dang,
This is ano, no,
da-da-dang.
logical. Kasi if 15 days ang letter B, Josh, yung half-life niya, first day pa lang ng ano mo, A, ubus na siya si A. So, lahat ng 1 mole mo converted into B. Or lahat ng 1 mole of A converted to B already. So, after 15 days, you expect 0.5 moles na lang, tama? Yung naiiwan
Opo.
for B, Josh. Then, after another 15 days, which is total, in total, 30 days na, how many moles na lang ang may iwan for B?
Uh,
So, hahatiin mo ngayon si 0.5, magiging 0.25 na lang or 1/4 mo. Okay, how about si C naman ngayon?
negligible.
Okay, so you can write that. Good, ayan. Tapos, since, anong mangyayari ngayon kay letter D? So, yung na-convert na letter B, yun na yung starting, ano mo, no? Starting na, ah, oh, meron yan. Ano na mangyayari sa B? Anong basis mo for letter C?
Wait, di ba po yung L and D does not change anyway?
Mhm. You now interpret this. So, oh, are you sure 1/4 mole lang yan?
Uh,
I have a question,
no, no,
Josh.
no.
Ah,
I mean the when. Ah,
mm,
the.
very good. Because that will be A1 is, you should have A1 mole, no? Okay, okay, good. 1 mole minus 1/4 mole left for B. Then the rest were converted into moles of D already. So because D is non-radioactive. That is the correct answer. Tama ito. Para we can, ano no, we can proceed with the next question. So for letter A, negligible or virtually we can say no, no remaining A. No A remains. And then 0.25 mole of B remains after 30 days. Then no B remains again. Yan. Or no remaining B. And then this will be 0.75 moles. So if we will analyze, parang ganito siya, Josh, no? Meron kang 1 mole of A. So lahat sila converted into 1 mole of B. But after 30 days, yan. So after 30 days, converted yan lahat to 1 mole of B, no? After 30 days, since 15 days yung the half-life for this is 4.5 seconds. So after 30 days, we know this should be 0.25 moles na lang. So ano nangyari sa 0.75 moles na B? Naging C na siya. Okay? So this is still D. Pero, since this one, the half-life is very fast as well, I think 1 second ito, no? So, after 30 days, automatic 0.75 moles of D should be left. So, you can have this diagram as well, no? So that you can clearly see what happens to your A as it is converted to B, to C, and then to D. Okay? So, tsaka yung mga corresponding half-life nila. So, I'll stop sharing lang muna or I'll share my
Ito po.
sige. Ayan. So, share muna ulit ako. Ayan, papapasa ko sa iyo mamaya. Share lang ako Then we proceed with number 10 para matapos tayo. Number 10. The radioactive nuclide cobalt-55 has a half-life of 17.5 hours. What mass of cobalt-55 remains from a 0.01 gram sample after 24 hours have elapsed? Parang similar to, no? Nasagutan na ba to natin kanong last time? Check natin. 1 year yung isa. Ayan, no? 1 year, cobalt 60. Ito, cobalt 55. Tapos hours lang yung half-life niya, no? So, ang tanong, what mass of cobalt 55 remains from a 0.01 gram sample after 24 hours have elapsed? Okay, I'll stop sharing. And then you now share your screen now.
Bro.
Sorry, next page ka na lang, Josh, para at least you'll be answering now number 10. 11 medyo mahaba-haba yun, alam ko eh.
Muted po kayo. Muted.
Nothing. Just continue.
Po.
Okay, so again for number 10, you have a radioactive nuclide na cobalt-55. A half-life is 17.5 hours. And then we're just asking for the mass of cobalt-55 remaining after 24 hours if you have 0.01 gram sample of cobalt-55. Cobalt-55. You start writing for the equation muna. What equation can be used?
Uh-huh. Parang mali. Ah! Kaya pala. Nakaano pala po sa ano. Mali yung na-input sa calculator. Okay.
So you will still be using the same kinetic equation. Yung favorite mong ln 80 over AO is equal to negative KT. That is the pertinent equation there. Ayan, sulat mo na para at least we can finish the problem set tonight.
Yun na po.
Okay, anong answer?
Yun po.
0.00603
Opo.
and then 2. Wait, double check mo muna, Josh. May mali ka kasi mali yung sagot mo eh.
What
You
could
read the problem again. Naku, yung mga ganitong ano
Bro,
ha,
literally
plug in.
1984. Literally. Bro.
So what is your error?
Ito po yung tawag na bra moment.
What is your error talaga?
Ito po yung mga evil problems.
Mm-hmm.
Why would you do such a thing to me po? No. My life is completely ruined po from now on.
Okay. 0, 0. Okay, good. So the answer for number 10 is correct. 0, 0, 0, 3865 or 396 ang sayo. Wait. Uh, what is your half-life, Josh?
Ano po?
What is your half-life? Check mo
Ah,
ulit.
wait a minute. Why is everything susi?
Hmm.
Why is everything susi po?
Oh,
Bro,
see? Recalculate now the value of x.
how could this be possible?
I
Literally,
don't
literally
know.
everything po that could happen wrong is happening wrong.
So the answer is 0. Ayan. Hmm. Are you sure? Can you double check kung ngayon talaga? Six one three.
Opo.
Double check ka ha. Kung if that given equation, and then 2 divide 17.5 and then I'll multiply that to 24. Then negative answer. Tapos ita times ko sa 0.01. Okay, iba yung sagot ko. You try to evaluate ulit. Try
Bro,
to do that in your calculator. Something is wrong or may mali kang ginagawa sa calcu mo. By the way, Joshua, X there is literally the remaining ano ba yung tanong? Baka ako pala yung mali, no? Tama nga. Remaining cobalt 55. Not the not the isotope formed after the decay of cobalt 55. So we're asking about the mass of the remaining cobalt 55.
this is this is blasphemy po.
Mhm. Ano na, sige, go ahead. What you need there lang, Josh, is x, not the 0.01 minus x. Literally x. What is cobalt 55 remaining? So no need to have this 0.01 minus x. Charge ko lang ito. Ayan. Same na tayo ng sagot. So that is the answer, 3865 grams. Okay. Then let's proceed now with number 11. Medyo mahaba-haba tong 11, no? So for number 11, Josh, nuclear waste disposal is one of our major concerns. We know that already, no, sa nuclear chemistry. So in choosing a safe and stable environment to store nuclear wastes, consideration must be given to the heat released during nuclear decay. So that's the reason why we're calculating the change in energy. No, every time we'll have a change in mass, it corresponds to a change in energy as well. No, and energy is usually released using radioactivity. So as an example, consider the beta decay of strontium 90. So the mass of strontium 90 is given, Josh. And then it will decay into yttrium-90. And then beta decay yan. A beta particle will be released. And then the half-life of this is 28.1 years. Tagal, no? Tagal ng radioactivity ni strontium-90. The yttrium-90, on the other hand, which is 89 point, the AMU of yttrium-90 is given, further decays as follows, no? From yttrium-90, you form zirconium-90 with the release of beta particle. With this, the half-life this time is 64 hours lang. So, approximately mga nasa ano lang yan, 3 days, no? Para maging zirconium-90 na siya. So, therefore, zirconium-90 will become is a stable isotope. So, doon humihinto yan. So, from strontium-90, yttrium-90, then yttrium-90 to zirconium-90. So, use the mass defect to calculate the energy release in joules in each of the above two decays. Okay, so what we want is you need to calculate the energy change for the decay of strontium-90 to yttrium-90 and the energy change from yttrium-90 to zirconium-90. Okay, so the mass of the electron is this one. Or parang ang baba, no? 5.4857 times 10 to the 24th mole. Okay, so that will be 0.00055. Ito na, binigay ko na
Bakit po
kanina,
to the
no?
24? Hindi ano po?
Pili ko
Bakit po to
dapat
the 20?
naka-grams to, no? Wait, I'll try to change this one, or convert natin siya. Or feeling ko negative 4 yan. May mali. Yes, negative 4 yan. 1, 2, 3, 4. Negative 4 to Josh. Mali yan. Negative 4. This should be negative 4.
Wait po.
Hindi kasama
It's
kapag
time for
graph. Ayan.
ito po yung ano, ito po yung
Annotate.
this
Ay,
calls for
shucks. Sorry.
Opo. This calls for some Superman.
Annotate. Ano yan 5.4857 times 10 to the negative 4 amo. Negative. Should be negative 4. Okay, or nagbigay na ako ng approximation dyan, Josh, no? Ito, yung kanina. Gagamitin pa rin natin siya. This one. Mass of electron is equal to 0.00055 amo. That is the same. 5.5 times 10 to the negative 4. Ayan. Asan na yung inano mo? Ayun. Ayan. Sakto na ba? Negative 4 amo. That's for letter A. Okay? So, for letter A, Joshua, I need to see two energy changes there. Strontium-90 to yttrium-90, then yttrium-90 to zirconium-90. The atomic masses for the three involved nuclei were already given. Then starting with 1 mole, yun ulit, parang yung ginawa natin sa number 9, no? Starting with 1 mole of strontium-90, calculate the number of moles of strontium-90 that will decay in 1 year. So that will be the question. Then for letter C, how much heat is released in kilojoules corresponding to the number of moles strontium-90 decay to zirconium-90 after 1 year yan. So I think after 1 year yan. Parang putol yung letter C, no? So let me check kung after 1 year. Yeah, after 1 year yan. So after 1 year, gaano kaya kadaming ayun nga, ay nako ha, tinago mo na naman to. Decay to moles of strontium-90 decay to zirconium-90 in letter B. Okay, so bali ganito for letter A, calculate the energy changes for both two decays. And then for letter B, calculate the moles of strontium-90 remaining after 1 mole. If you have 1 mole ng strontium-90 after a year, then how much heat is released in kJ if that that starting material for B, no, or in B will happen. Okay, so I'll stop sharing na and then you can now share your screen. So that is number 11. Hopefully, ayan, parang within 5 minutes siguro, you can finish 11, no? Or maximum na siguro 10. Okay, go ahead.
Mag-swipe. Aha. nagsusulat. Yun lang.
Ayaw.
Hindi, nagsusulat pala. Na ano, nag-glitch. Hindi, nag-glitch. Tang, 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 tang. Tang, tan, 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 ha? Bakit? Why is it pangit? C minor moment.
Please take note, Josh. The question is asking in kg. So, i-divide mo lang din naman yun sa
Enjoy na po.
1,000. In J lang ba siya?
Apo.
Okay,
Enjoy
check.
no.
Oo nga. Sorry, in joules lang. Sorry, in joules nga. Tama na, tama na. Akala ko
Ano po?
kg.
Yung ano po,
Ako kasi
tricks to,
lagi,
para
lagi,
yung students po hindi maka-perfect score.
lagi ako nasanay kasi sa kilojoules.
Kilojoules.
Okay, correct.
Ha? Coins na song ba po? Ah. Tong ten tarararang.
36.4. Okay, gets. Josh, check your conversion factor. 1 amu is what? Ilang ano
Over
yon? 10 to
1
the,
amo is Avogadro's na 1 over Avogadro's numbers rule.
which is ang Avogadro's number ay nakagrams, right?
Abo.
Ang joule ay kilogram meter squared per second squared. Kaya yun yung ano ko, dilemma.
So I will just divide by something. By
Kasi you
1,000.
should, you should recall, hindi siya ano,
Aba,
you should
sabihin
recall 1
kilojoules po
amu.
agad. Kilojoules po agad pag ganun. Divided by Avogadro's
Hindi siya
number.
kilojoule. Joule pa lang yan.
Iba pa
Wait,
rin.
I'll demonstrate. Yan. Yan. 1 kilogram is equal to 6 point, the conversion is 6.022 times 10 to the 26 amu. So, sir, saan to nakuha? Kasi 1 gram is equal to 6.022 times 10 to the 23rd amu. Tama, di ba, Josh?
Abo.
Okay. But 1 joule is equal to 1 kilogram meter squared second squared. Ayun o, kilogram. Kaya ito yung need mong gamitin. Okay? Gets? 1 joule is equal to kilogram meter squared second squared. Okay, so tama naman. Same tayo ng value na nakuha na 5.59 times 10. Dito lang tayo nagkaiba. So please take note to easily convert amo to kilogram, Josh. This is the conversion. 1 kilogram equals 6.022 times 10 to the 26 amo. Hindi, tama na yan. Negative 15. Correct. Negative 15 ang sagot. Okay, sige. Continue. So recall yan. Conversion factor is 1 kilogram equals 6.022 times 10 to the 26 amo. Correct ulit. 2.84 times 10 to the negative 13 joules. So we're done with letter A. Ngayon, what is the total energy produced? Sige, i-total mo muna pala yan. Kasi from strontium going to zirconium. So how much energy is released? Para lang magkaroon ka ng idea from strontium to zirconium. It means exothermic naman. Negative sign there, it means it's exothermic. It's being released into the environment. So that will be what? So of course, parang ang makakuha mo dito si negative 13 eh. No, kasi siya yung may kita mo kung gaano kaliit yung unang reaction, no, per nucleus. Ayun, negative 2.89. Correct. 891 times 10 to the negative 13 joule per nucleus, no? So ibig sabihin, Josh, ganito yan. If one strontium 90 will be decaying into zirconium 90, 2.8918 times 10 to the negative 13 joule will be released. Okay?
Yes.
Next, we're good. For letter B, ang hinahanap dito, Josh, will be
it's some bar.
moles of strontium 90 that will decay in a year. Sige, go ahead. So starting from 1 mole of strontium 90, ilan na lang yung matitirang gaano kadaming strontium 90 yung magde-decay. We're not asking for the amount of moles of strontium 90 left after a year. Instead, how many number of moles of strontium 90 will decay after a year? You can start by writing the pertinent equation used, no, for this for solving this problem. Okay, correct. Yan. Yan, 1 mole ka eh. Tama yan, tama. You're doing good.
Tang tang tang
Oh,
tang.
80 is your x. Ano dapat yung AO mo? Dapat you should have their x over 1. Para
I
at
cannot
least you
find the
can...
I cannot find the half-life po eh. Where's the
Hmm,
half-life?
andyan ang half-life.
Ayun!
Pinakita yan.
Brrrra. Pam, 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 pam.
Good, ayan. Nasa equation siya mismo, no?
Yay, math error. Dun, 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 dun. Dun, 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 dun.
What's your time? Letter T.
One po.
Okay, correct. So, pero ayan ay moles na ano? Moles of strontium-90 na ano?
Moles of strontium-90 na
Present after a year. Correct?
mabo.
But we're looking for the amount of strontium-90 or the moles of strontium-90 that decayed after a year. So, what will be the answer? Ano to ha, note nito Josh ha, this is 80 kaya nga mahalaga na ano eh, ino-note natin siya. So 80 or X is equal to 0.0975 mole of strontium-90. This is left after a year, no? But we're looking for the number of moles of strontium-90 that decayed after a year. So what is the answer?
1 minus this one.
Okay, good. Sige, kunin mo. Para then, ayan na yung ibabox mo. Okay, good. That is the answer. 0.024 moles of 2436 moles of strontium-90 left after a year. Left after a year. Decayed after a year. Okay, that's letter B. You now proceed to letter C, Josh. So with that given moles of strontium-90, how much heat is released, no? Gaano kaya yan? So, syempre from moles, please take note, per nucleus, nakuha mo na yung energy na na-release. So, kunin mo muna yung nucleus for the moles given of strontium-90. And then, you can now get the energy release after a year. Go ahead. Sige. It's letter C.
Pero parang, so I will go through both reactions po.
Tama, both reactions. Kasi total energy release na eh, no?
So then how will that
So,
work po?
kunwari, since this one already decayed after a year, 0.0246 moles. So, you need to find the number of nucleus involved or yung nag-decay na nucleus.
Oh no.
By that, dun sa total energy no release from strontium going to zirconium-90. Off lang ako ng video, nag-unstable siya. Para at least ano. So I highly suggest you start with the number of moles of strontium-90 that decayed after a year.
I have an
Okay, so
idea.
from
Genius.
the most of strontium
O kaya
90 that we can
that's why
study.
this will be very genius po.
Why? Sige, show me the solution.
Uh,
Okay, tama. For letter C, I think that will be letter C. In kJ yon. Yung letter C pala yung in kilojoules. Kasi malaki yung value niyan eh. Okay, so correct. You need to multiply it to the
genius.
negative 28.8918 times 10 to the negative 13 joule per nucleus. Okay, that's in joules. But what we want is in kJ.
My reaction po looking at the joules.
Okay, reaction. In kJ na siya. So, the answer should be, para same tayo, no? 1, 2, 3, 4, 5, 6. Okay, correct. So, that amount of energy, no, is released after a year. Gigajoule. Akala ko 6 joule ito. Yun pala GJ siya. Correct. So this is correct. Good. We're now done with number 11. Okay, so we're now proceed with number, I think wait lang ha, double check ko. Yes, 12, 13, 14, 15, pwede sigurong pakita ko na yung problems and then sunod-sunod mo siyang isolve ba? Because these are really problems that we already solved. So parang type siya ng problem na na-solve na natin. This one. Okay. So for number 12, so the nuclide thorium-230 decays to radon-226, no? Then by emitting alpha particle. So given yung mga mass ni thorium-230, ni radon-226, saka ni alpha particle, what we need is the energy release in the process in joules per nucleus. So joule per nucleus. So ang kamukha niyang problem, Josh, ay si number, sino to nga? Ito, si number 7. Okay? So number 7 at saka si number 12, magkamukha yan sila. Okay? Then for number 13, the half-life of iron 59 is 44.6 days. How long will it take for your 95% of your sample of this nuclide to decay? Basically, the same with number 10. So number 13 and number 10 magkamukha. Then number 14, di ba may meaning tayo ni Curie? So Curie is disintegration per time per unit of time din So a sample of calcium 45, which is a beta emitter, has an activity of this one originally. After 60 days daw, nag-decline to 0.0775 microcurie. So what is the half-life of calcium 45? So ang kamukha niyan ay yung may disintegration per minute. So ito yon, number 8. So ayan. So number 12 ay kamukha ni number 7, number 13 ay kamukha ni 10, number 14 ay kamukha ni number 8. Tapos yung number 15 ay kamukha lang din ni 12, number 13, no? So the half-life of tritium is 12.3 years. So if I have the 48 milligrams of tritium released from a nuclear power plant during course of an accident, what mass of this nuclide will remain after 12.3? So this is really easy, yung unang tanong. And then after 49.2 year, so almost ano no, half a half a century.
Alam ko
Gaano
yan,
kadami kaya?
madali lang po
Hmm.
siguro to. Hopefully, hopefully.
Oo, madali yung 12 to 15. Kaya nga pinagsama-sama ko sila, no? Sige, go ahead. You can now solve from 12 to 15. So, 12 to 15.
Ayun po makapipiste, sayang.
So, ano, ayan. Next page ka na lang for number 12, 13, 14, and 15. 12, 13, 14. For items. What is that, ano, link?
Definitely nothing suspicious po.
Number 12, okay, go ahead. Okay, so being a curious kid,
Ano po?
being a curious kid, I trust you. This is safe.
Please,
Tinype
please.
ko yan mano-mano, no? I type it
Ikapipis niyo
manually.
po.
No.
It's
Anyway,
very,
continue.
It's a very safe website po. I trust me po.
This is what you're drawing a while ago. Anyway, I'll go ahead. Solve for that one. For number 12. For number 12, alpha particle naman yung na-release.
Kung ano po, yung yung antimatter po,
Ah,
kung may ano po, kung antimatter has mass, then what has negative mass? If even
sorry.
antimatter has mass po, then
Hmm.
what has negative mass?
If it's a negative mass, therefore it's not a matter anymore. No?
Kasi yun ang definition ng matter eh.
Ayun, correct. Babalik ka ulit sa definition. If any particle will not have a mass already, wala na yun. Hindi na siya matter.
Iba yun. Hindi siya
Yung ano po, yung photon.
It could be something, but it's not.
It's a form of energy, di ba? Yun nga yung parang foundation natin last time nung nag-umpisa tayo, di ba? So far, to make things less complicated, you do only have two things in the universe, matter and energy, and they interact together. So upon this interaction, apparently, yun, nag-give birth pala yun ng mga antiparticle mo, yan, or antimatter. So far, yan yung mga alam natin the antimatter, matter, tsaka yung energy. Baka malay mo, meron pa tayong ma-discover na beyond that.
Anti-energy moment. Yay.
Grabe yung anti-energy. Pero we don't know, no? We don't know. Malay pag nag-big crunch, kung totoo yung big crunch, no? Parang magko-collapse. If you're a fan of ano nga ito? Anong show yun? Umbrella Academy, yon. Nagkaroon naman siya nag-compress naman yung universe. So instead of expanding yung universe, hinihigop niya na yung universe.
Me after escaping the universe altogether. I won't die po with the other humans.
Or it means you need to have this solo na time space continuum if that's the case. If you can escape the universe, something
Me
like
after
that.
escaping the universe only to find out there's no oxygen in space, so I died.
If you will discover a time space continuum, escaping our universe today, definitely it will be easy for you to create a suit, or a instrument or a device for you to make for you to be able to survive having without oxygen, or an environment without oxygen.
Me after changing the time space continuum altogether so I can survive in a vacuum.
Anyway, calculate muna. That will be joule pa lang yung makukuha mo. Please take note 1 kilogram is equal to 6.022 times 10 to the 26 negative 3 kg.
Down.
Yeah, negative 13. So double check ko kung tama yung sagot mo. What's your delta M for this? Yan, dinire-diretso mo kasi Pero yung amo mo, that's correct. Same naman tayo ng amo. Negative 4.6125 yung
So
akin.
dapat it's in the calculation.
10 to the 14th. Correct. So, okay. 7.6594. Yung akin. 6-4. Almost almost the same naman. I don't
Imagine
know
not,
Hindi ako
imagine
kasi
not using the
nag-ano.
calculator values po.
Okay, so 7.6 or 7.66. That is the answer. 7.65 instead. Okay, acceptable. Negative 13 kJ per nucleus. That is kJ per nucleus. Okay, okay. Okay, proceed with now to number 13 now. Dali lang yun yan, 13. So we're finding how many days, no? For number 13, how many days will it take for your 95% of iron 59 having a half-life of 44.6 days, no? Will decay. Yan, yung anong favorite equation mo yung gagamitin? Our favorite equation,
Our
the
favorite
kinetic
equation
equation.
is
Sobrang
flow.
natin. Oy, dapat na yan ha? Josh, dapat super master mo na tong equation ni
Yan po yung
first order
favorite.
kinetics. No, first order kinetics, no? ln 80 over AO over equals negative KT. That is your okay, very good. K is equal to ln 2 over half-life times T. Very good. So we're looking for T here. So you can easily plug in the data and then
Solve.
calculate letter T. Pwede ka mag-shift solve dyan. Okay. Sinolve mo na. That's
Yes,
your
that's the
answer already.
ito po yung power of the shift solve.
Okay, the answer is 192.8 days. That's my answer eh. Same naman tayo. That's correct. Next, number 14 naman. Number 14. Okay, correct. Number 14. So for number 14, we're calculating or we're finding for the half-life, I guess, Yeah. So, binigay yung mga
Our
disintegration. Disintegration per unit of time. Okay, for your half-life, 163 days. And that is the answer, 163.2 days yung akin. Okay, correct. Next, number 15. So for number 15, we're finding the amount left, no? After 12.3 years and after 49.3 years for tritium. So you started with 48 milligrams of tritium. Very similar na equation.
So,
Wait lang, why are you laughing?
Nakakatawa po.
Anyway, naman eh. Naka-blurred. Go ahead, 15. Same, same equation yan. ln 80 over AO equals negative ln 2
49.2
over
is
beta.
just 3 times 12.3. So I can actually do this manually.
Yeah, actually. So what is the answer? Correct. Okay, good. Oh, 6 yung sagot after
Yeah.
49.2 years.
Abo.
Are you sure? After 49.2 years, 6 ang may iwan?
Abo.
Sige, you try to solve. 49 point, ano nga yun? 49.2 years. Mhm. Times 48. Mali ka. Sige, check mo yan.
What?
Check mo yun.
Literally 1894.
After 49.2 years. Kasi nag-mental math ka eh. Sige, pwede naman actually mag-mental math talaga. Pero if you will check that using our equation, you'll be seeing a error, no? Or kung makita mo na kung saan ka nagkaroon ng lapse dyan. Ayan, correct. So, 2 raised to 4 kasi dapat, no? Yung factor mo. So, the answer will be, of course, 24 milligrams after 12.3 years. And then, after 49.2 years, you'll be having 3 milligrams na lang na left. Okay, so we'll now proceed with number 16. Number 16 muna tayo, no? Number 16. For number 16, Josh, the quantity of a radioactive material is often measured by its activity. Of course, we know this already. So I think baka dito tayo matapos daw sa 16. Itong 17, mahaba kasi pa siya. Saturday natin ito gawin, no?
After telling the entire the entire plot of UNCLE.
Anyway, 17 kasi mahaba-haba siya na store.
Dapat po, yung 17 po lagyan niyo po yung buong plot ng UNCLE
Hindi naman. Anyway, kasi it's a combination. It's an integrated problem, no? You need to write there a nuclear reaction, tapos kinetics, tapos yung energy. It's everything. Plus the biological effects of radiation. So maganda yung 17, parang good question siya to end our nuclear chemistry topic, no? Anyway, for number 16, ito muna tayo, 16. So this is also quite long siguro na no, or it's more on understanding the problem. So the quantity of a radioactive material is often measured by its activity. So we know this already. Becquerel yung SI, measured in curies or millicuries rather than by its mass. So in a brain scan procedure, this is the mass of your patient, 70 kilograms, injected with 20 millicurie of 99 M technetium. So we know this already. M stands here for what? M
Milli.
O hindi milli yan. 99 MPC.
What's MPC? I forgot.
Oh, what's
Yes,
that?
this the metastable.
Very good. That's the metastable technetium. And then yung technetium, ibig sabihin if it's metastable technetium, ano ano kagad yung i-expect mong decay mode? Definitely you'll have a what?
Uh,
Kasi from 99M technetium metastable technetium.
I
So
forgot.
if it
Yes,
means
gamma, gamma. Sorry, sorry po.
good.
Nakalimutan.
Gamma kagad siya. Kasi para maging 99 technetium siya, no? Or technetium 99. So which decays by emitting gamma ray photons with a half-life of 6 hours. So medyo mabilis, no? 6 hours yung half-life niya eh. Of course, this is being used in medicine kasi. Given that the RBE, recall yung RBE mo, no? Given that the RBE, the relative biological effectiveness of these photons, gamma ray photons, is 0.98. Di ba, naalala mo yon yung RBE is a factor that we need to multiply to your REM. Di ba?
To get
Para makuha mo yung, to get the, sorry, you multiply this RBE to your RAD.
to
RAD.
get RAM.
Oo,
Yes.
gets. Yes, correct. To get REM. Okay? And if you will recall, approximately 1 yon for gamma ray and beta. Diba? Si gamma ray tsaka si beta, approximately 1. Pero for alpha, that's 10. The factor is around 10, no? Calculate the REM dose received by the patient. Assume all of the 99 metastable technetium nuclei decay while in the body. And then the energy of a gamma ray, so binigay yung energy ng bawat photon, gamma photon, no, is 2.29 times 10 to the negative 14 joule. So what's the technique here? Anong parang technique mo dito? Parang we need to calculate what? The energy of your photon, no, from your 20 millicurie metastable technetium. Okay? Tapos to get the REM. Okay? Sige, go ahead. Hanapin ang ano mo muna dito, parang I'll give you a clue, no? Parang kailangan makita mo muna yung decay per unit of time nung metastable technetium. And then from that, you can get the number of nuclei na magdedecay. And then from the number of nuclei, makukuha mo na yung joules. That will be your rad already. Kasi di ba ang rad ay joules, no? The total energy absorbed by the patient. Si rad ay is anong unit nino? Ni rad is a unit of what, Josh? According to biological effects.
Parang
What's the mean?
absorb dose.
Yes, correct. Correct. Absorb dose. Tama, absorb dose. Si REM ay effective dose.
Bakit
Good.
po
Okay.
ginawa po po ng Siebert, mas kung yung REM naman po is just 100 of Siebert.
Hindi ko rin alam actually. Ito yung sobrang, kahit nga ako kapag inaaral ko to, litong-lito ako dun sa ano. Napakadaming unit.
Opo, just use centi-Siebert para kung
Or just stick with Siebert na lang, no, as a unit of unit of effective dose.
Kung po nila, hector o kaya centi-Siebert na po para
Yeah, para lang sa to express the REM, no. Anyway, go ahead. You can now share your screen and then solve for the REM. We're looking for the REM, no? Yung na effective dose na nakuha ni patient by having that situation. So again, you started with 20 millicurie of metastable technetium 99. And then we assume here this 20 millicurie of this isotope will be decayed, no? All throughout na. So, ngayon, ang RBE ng gamma radiation is binigay, 0.98. And per photon of your gamma, 2.29 times 10 to the negative 14 joule. So, parang ang clue mo dito, ang makuha mo muna yung nuclei na involved dun sa 20 millicuries. Pag nakuha mo na yung nuclei, you can easily get the joules, no? Kasi ang energy naman ng gamma yung nagbibigay talaga ng dosage eh. Okay? So, kada decay ni technetium kasi, isang nuclei, isang nucleus ni technetium will release 1 gamma photon, which is equivalent to 2.29 times 10 to the negative 14 joule. Okay, go ahead. I'll give you the liberty for you to strategize on how to solve this. So this will be our last problem for tonight, number 16. Ang, ang clue mo is kunin mo muna from Curie, convert that into decay per unit of time. We have the definition of Curie na. Balikan mo yung definition of Curie natin.
Hala.
Kalimutan na.
Forgot.
1 Curie, bigay ko na yung ano ha, yung
Equals
conversion.
3.7 times 10 to the 10 yata po.
Correct, tama. Good. 3.7 times 10 to the 10th decays per second. Di makukuha mo na yon kasi 1 Curie yun, kaso millicurie ang ginagamit kasi natin, no? Then from there kasi, you can get the actual number of nuclei naman. That will be rate
po ginamit
equals...
nila? Ba't ginamit po nila yung average ng 1 gram of 1 gram of radium? Hindi po 1 nanogram of
1 gram
radium.
of radium, no? Hindi ko rin alam. I think laging special yung 1 gram. I really don't know.
Bakit gamitin 1 nanogram? Hindi po yung practical eh.
Or feeling ko ano kasi siya, historical, no? Because kasi itong mga radium kay Curie to nag-start eh. So might as well because like what I mentioned practically speaking pala Josh, no, it's quite difficult to measure less than 1 gram. So mas malaki yung error. Kaya ideally dapat mas malaki yung mass mo para mas less yung error. Sige, go ahead, solve mo muna. So from Curie, decay per second.
What's the gray again? Nakalimutan ko pa yung gray.
Ang gray naman ay, ako din,
yung gray po ba, anong siguro, rad? Yung rad pala po yung dapat kailangan natin.
Ang gray ay rad, absorb dose, ang kapantay niya. Si Shevert ang REM. Rad ang hinahanap natin, good. Rad ang hinahanap natin.
Rad is something. Rad equals
1 rad is equal to 0.01 gray, or it's the absorption of 1 times 10 to the negative 2 joule per kilogram.
Then what's 1 gray po?
1 joule per kilogram. 1 joule of energy na na-absorb ng per kilogram dun sa irradiated material.
Joule per kilogram. Okay. Joule.
Okay, asan na? Sige, go ahead. Paki-check, Joshua, it's 10 to the 9. Baka may namali ka. Remember, it's millicurie, ha? So, I suggest from millicurie, convert to curie, and then, okay, good na.
Ang typo po.
Okay, so that's decay per second na, no? So, from the decay per second, that's your rate, right? So, once you have your rate, ano yung susunod natin? Kailangan mong kunin yung nuclei. So, to get that, di ba recall, meron tayong equation na ito. So, yung rate is equal to Kn. Wait lang. Annotate. This one, no? Naalala mo to? Rate is equal to Kn. So, this NO is the number of nuclei. Number of nuclei involved in your radioactivity. Okay, sige, go ahead. So, ang problem mo, wala pa yung K mo, but you can calculate K actually from the half-life. Then, just make it into the unit of time na same dun sa becquerel, which is second. Okay, so ayan. Did you get the number of nuclei involved na? For the 20 millicurie? NO is the number of nuclei involved dun sa rate na nakuha mo, no, from the millicurie. But the problem here, you don't have K pa. But you can easily get K, no? So calculate first K. So make it into second, no? Okay, so what is the value of K now?
Mhm.
Binigay naman yung, I think, binigay yung half-life ng technetium, 6 hours.
Okay. So, uh-huh. Alam ni K. Yes, ln2, negative ln2.
No, it's not negative ln2. Negative kT yun yung equation. But K is equal to ln2 over half-life lang.
Like po.
Okay.
Wait, bro.
Okay, so that's our K, no? So once you have your K, you can now get the NO. Ano yung rate mo? Yung rate mo, ito, 7.4 times 10 to the 8 decays per second. So how many nuclei of technetium is involved with that? 3.21 and then 2. Why is your K negative, Josh?
I don't know. I don't know.
Hindi siya dapat negative. ln2 over half-life lang siya. You already have the value for the nuclei. Sige, check natin na.
Abo.
Okay, that's correct. Wait. Paano yan? Hmm. This is yung 0.1155 per second ba siya or per hour, Josh?
Per hour. Okay. So
Mali.
divided by
Correct.
36.
Yes.
Bruh! This is ano po, this is the pinnacle of emotional damage.
Yeah. So, it means you have a wrong. Okay, good. Check natin kung ilan na yung ano mo. And what's the unit for that? Yan na yun? Per hour, ha? This is per hour, Josh. This will be converted into per hour. So, kung per second yan, magiging, this is not kasi per second pa eh. Per hour pa to eh. Okay? So, if you convert that into per second, you'll have 3.2, 3.21 approximately, times 10 to the negative 5 per second. Okay? So, with that, use now the becquerel, no? So, 10 to the 8 tsaka negative 5. So, how will you get the NO? So, NO is equal to rate over K. Ayan. Ano yung number of nuclei involved na, Josh? You
Okay,
express
so
it in your scientific notation.
Hmm.
Times 10 to the 8, sure. Ang rate mo, ito na ha, naka per second na. I already
Per second na
give it to you.
magko-convert ako. Okay.
Kasi syempre, ang gagamitin mo, second, tsaka ito, no? Kasi sila yung same unit. This is 7.4 times 10 to the 8 decays per second eh. Right? So, ayan, same sila. 10 to the 8 pa rin. That's the number of nuclei already.
Abo.
Sige, what is your rate? Your rate is 7.4 exponent to the 8. And then, i-divide ko sa 3.21 exponent to the negative 5.
Nangyari.
I have a different answer than yours.
Ayun.
Okay, good. Okay, 2.0. Okay, 10 to the 13th. What is the unit this time? Sino to? Number of technetium nuclei. Okay, so ayan, nag-ano ako eh. Nag-unstable. Ayan, technetium nuclei to. Ayan yung 99M technetium nuclei mo. From there, Josh, you need to now get the energy, no, of your nuclei. So each nuclei emits a photon of energy 2.29 times 10 to the negative 14 joule. So the total energy absorbed by the patient is what? Sige. So
Okay,
go ahead.
so
Next page mo na lang.
tang 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 tang.
Meron palang note dito, Josh, ha? 'Di ba? The RB is 0.98 and only 2/3 of the photons are absorbed by the body. So para makukuha natin yung effective dose. So from the nuclei release, calculate the energy. Tapos hindi lahat yun ma-absorb, only 2/3. So that you can only get the energy absorbed by the body. Sige, go ahead. So that we can end the session na rin, no? So that yan, you can rest a bit. So you start with, ano yung value mo?
Hindi ba po? Hindi nagkamali po sa ano eh, para
Sige. So you show your solution para after we end our session, pwede mong picturean yung ano natin, solution. So you start with the number of nuclei. That's 2.305 times 10 to the 10 to the 13 nuclei. Okay? Per nuclei, isang gamma photon ang mapoproduce. Then per gamma photon, may equivalent na energy. Okay, good. Ngayon, sino ngayon yan kapag na-solve mo na? That is the absorbed, no? Absorbed by the patient. Total energy absorbed by the patient. Ngayon, ang kailangan mo is energy per kilogram of your absorbing material. So whatever the value will be, divide that over what? Okay, kasi 0.001 rad eh. Okay, correct. So, 1 rad rather is 0.001 gray. Okay, and then from there, calculate now the REM. Rad times the RBE. So, i-convert mo ngayon yan sa REM. O,
Ano po?
convert that to REM.
Nakakainis po yung mga...
Ay, sorry,
Yung
sorry.
mga...
Convert that to rad. Yung gray mo,
Ano
i-convert mo na sa rad. Para at
si
least,
Dito Rad ulit?
mm,
Ba't ko po kasi ang daming unit? Sana isa na lang.
ewan ko sa'yo, bakit kinonvert mo kasi sa gray kagad? So,
Joules per
rad
kilogram po.
talaga yan eh. Mm. Joules per kilogram. Oh, joules per kilogram nga. Joules per kilogram. Hmm? Hindi yan. Tama ka, joules per kilogram yon. Gray yan. Pero,
Ano po yung rad?
1 rad is equal to 0.001 gray. Diba? Naalala mo yon? Yung sinabi ko kanina. 1 rad, sorry. 1 rad is equal to 0.01 gray. 0.01, sorry. 0.01. So what will be the rad?
Wait lang. Ang baliktad.
2.30. Double check ko yung sagot mo. Exponent to the 13 times 2.29 exponent to the negative 14. Tapos, i-multiply ko sa 2/3. So, 0.35189 35189 joule. Okay. So, joule per kilogram. So, i-divide ko sa 70 ito. Ngayon, i-multiply ko sa 0.01. Tama ba ako? So, 3 ay, 1 rad is equal to 0.01 gray. So, gray ang nakuha natin. Divide 0.01. Okay, so may rad ka na ngayon. Tapos ito times mo sa 0.98, very good. And that will be the REM. 0.49 REM. Okay, that's good. Or, correct, kung gusto mo ng millirem, ita-times mo na lang to sa 1,000. 492 millirem. Correct. So this is your, by the way, this is your what, Josh? Sa biological effects ng radioactivity. This is known as your what?
Your, I don't know, effective dose.
Okay. Pero if you want yung absorb dose talaga, ito yon. Yan, this is your absorbed dose. Which is also equal to that 10 to the negative 3 gray, no? So, kasi yan lang talaga yung na-absorb ng ano, ng katawan. Okay? So, with that, ayun. So, thank you so much for tonight, Josh. I'll be meeting you again sa Saturday, but that will be solving first with number 17 or for number 17. And then we'll proceed immediately after that. We'll proceed with electrochemistry na. Okay? So, ayan. Thank you for tonight. Ayan. So, medyo, yes po, napahaba lang po sir sa problem na to kasi marami po talagang units na involved dito eh. Okay? So, yon. So please try to answer number 17, Josh. Kayang-kaya mo naman na siya masagutan. Okay? So with that, thank you so much po and enjoy the rest of the night. See you po on Saturday. See you, Josh, on Saturday.
See you po. Ayan po.
Sige po. Thank you din, sir.
Sige po.
Okay.
Bye-bye
Yeah.
po. Thank you po.
Ang tawag doon, enjoy your dinner. Ako po magdi-dinner pala.
Abo.
Okay, sige po.